Continuing the lesson with the application layer protocols. We have different types of the application layer protocols, including the DNS, DHCP, SMTP, POP, HTTP, Telnet, and FTP protocols. Let's take a look at them one by one and describe them. The DNS server, the domain name system protocol, which is working with the domain names and IP addresses. We have to answer for these questions first. What is the IP address and what is the domain name? To describe it well, we have to take a look for such kind of example of the communication. So we have two persons and they have the initial dialogue. Like, hello, my name is Bayrabel, says one of them. Hi Baga, and what? And imagine that this person is not familiar with our names. Okay, and it's so difficult to remember such kind of a strange name like a Bayrabel for him. He say, so my name is Bayrabel, but you can call me Bake. So it's like a simplified version of the Bayrabel. Nice to meet you, Bake. You can call me Sake. And let's take a look for this example where we have the interaction of two computers. Say, hello, I'm 192.168.102.11. And he say like, hi, 192, and it's also difficult to remember for the person to remember such kind of address. And he say like, I am 192.168.102.11, but you can call me gmail.com. So instead of writing this long numbered address, we can just write the gmail.com as an example. Oh, nice to meet you, gmail.com, says this computer. So after this comparison, we may say that IP address is like a name in the life of the people, and domain name is like a nickname. So as it was named by Bayrabel, nickname is Bake. Bake is much easier to remember than the Bayrabel, and the gmail.com is much easy to remember in comparison with the IP address 192.168.102.11. So the DNS server actually is doing what? This mapping. So it has the domain name and it has the IP address in its table. And how DNS works? Let's take a look DNS in the process. So when the client opens the web browser and types the IP address, in this example it is just cisco.com, server receives this, the DNS server receives this request, and after what it's looking for its own database. In case if it is finding out the IP address of a given domain name, it is replying for the client with this IP address. And after what, client is able to communicate with this web server. And the work is done. To take a look for the domain IP addresses of any domain, you can take a look by using the nslookup application tool. You can run it through your CMD if you are the user of the Windows. So let's take a look and just type nslookup, and after what, any domain name like google.com. And you may find out here that you have one domain name google.com and you have multiple IP addresses. It's okay, because it doesn't mean that we don't have such kind of rules. One domain name belongs to only one IP address and vice versa. So we can have one domain name and we have multiple IP addresses which are bounded for this domain name. And like and vice versa, we may have such kind of situation like we have multiple domains which are bound to single IP address. Or you can just take a look for this IP address. And for example, our university's IP address is looking like so like this 10.100.105. Alright, so then let's take a look for the hierarchy of the DNS servers, and let's take a look for an example of the domain name which is looking like mail google.com. From this example, we may find out with you, like as you see, domain name is splitted by using these dots, 1 and 2. Okay, this dots defines the level of the domain name. Starting from the right side, this is the top level domain name. It can be also called as just the TLD, top level domain. Second level domain and third level domain. So here in this example we have actually it's like first, second and third level domain names. It can be also longer domain name. It can have 4 or 5 levels and so on. For example, let's say cos.mail.google.com and +1, for example, example cosmail. So it's not limited only with the 3 names. And by the way, when you are writing the domain like google.com, and when you write the domain name like www.google.com, so they are actually same. Okay. Why they are same? Because when you type google.com, by default here is written www. It's like a, it's like a world wide web. So you may just forget about it and just write this one. So to do not lose your time if you are losing time for typing this 3W. All right, now let's take a look for the hierarchy, which is represented here. So root level domain servers. So we have the hierarchy of the DNS servers. The root level DNS servers are responsible for the top level DNS servers. So they know all about the servers which are storing information about different TLDs. For example, all servers which are responsible for the Kazakhstan domain zone. And the top level domain servers, actually they know about all the servers of the secondary level domain servers. Like they know all about OK or NURKZ or SDUKZ and etc. And the secondary level knows about all the third level domain names. Like inside OK, KZ, we have different domain names of the third level, like mail, www, and so on. Let's take a look for a small example to understand this hierarchy more better. Let's say like this. In this example, we have communication between client and the mail server, like mail.google.com web server, let's say. We have to be connected, so let's have here the cloud, like an internet connectivity, and all this stuff, all these devices are connected, are bounded by the internet. Now, when your client is going to have access for the mail.google.com, it first of all has to have the IP address of the mail.google.com, which is 173.194.45 and 85, an example. Well, what our computer is doing? Our computer actually is directs its request to the local DNS server, whereas the local DNS server is the server which is placed and usually it is placed in the ISP, in the internet service provider. For example, like in AT&T or maybe Kazakh Telecom in our country. So, and our client is making request, like, and in this request, do you know mail.google.com's IP address? And our local DNS server looks for its own domain DNS table. In case if here we'll have this value like mail.google.com with an IP address 173.194.44 and 85. In case if we will have this value, so then a local DNS server will immediately provide the reply. And afterward, our client will have access to this server. But imagine that we don't have this value in our domain name table. Let's take a look, for example, when our local DNS server doesn't have IP address of mailgoogle.com. In this situation, our local DNS server starts to make research from root DNS server how to find out the top DNS server which is responsible for com TLD. So, and now our server, local DNS server, will make a recursive request. First of all, it will ask from its root DNS servers who knows the top level DNS server who is responsible for com, and we'll have reply. Like reply will be ask from server 111, for example. Afterward, our server will ask from the server 1111 and will ask the question, do you know how to find the secondary DNS server who is responsible for google.com? And afterward, it will give reply. For example, its IP address is 2222. And the next, we'll contact with the server 2222 with the question, do you know what is the IP address of mail google.com? And it will give us reply. Reply will be given as 173.194.44 and 85. After server will receive the last reply, it will write it into its own DNS table the values like mail google.com and IP address 173.194.44 and 85. So this part, which is from the right side, is called recursive DNS requests. So this part, so let me write it here. Which is done by a local DNS server. And only afterward, local DNS server will provide us information about this IP address. Then our clients will contact mail google.com by IP address 173.194.44.85. This is how DNS servers are working, and this is how hierarchy of the DNS servers is looking. Next protocol is the HTTP, the Hypertext Transfer Protocol. Before answering for the question what is the HTTP, let's first of all take a look for the hypertext. What is the hypertext is? When I ask from my students what is the hypertext, mostly they answer like hypertext is the hyperlink. But actually the hypertext consists of the hyperlink and other things. Like when your communication is done between client and server, that information which is traveling between server to client is called the hypertext. And the meaning of the HTTP protocol is the Hypertext Transfer Protocol, the set of rules which is making transportation of the hypertext. When you type the IP address of the domain name of the cisco.com, so here we don't see the process which is happening on the background, I mean the DNS process. And imagine that our client already knows the IP address of the cisco.com and is making request with the get index HTML from cisco.com, and HTTP server gives us the HTML code, and actually this HTML code now is the hypertext. It is received by the client, and client will show you the output of this web server content. The output shown you by the protocol, which is called with the application which is called the web browser, and the HTTP is responsible just only for the transportation of this data. Alright, let's take a look for the question. At least what your friend have to know about you to be your friend. My answer is the name. Without name, you are not able to be the friend of the person. And another question, at least what your friend's computer have to know about your computer to make connection with your computer. The answer is the IP address. Now, let's take a look for the protocol which is called the DHCP, Dynamic Host Configuration Protocol. If we'll take a look for the description of the protocol, Dynamic Host Configuration Protocol, we will find actually the description of the functionality of the protocol. Protocol is the set of rules that dynamically configures hosts. Host, it is end device. For example, you have the computer, and your computer is going to be connected to the network by using, for example, switch. If your computer wants to have a proper relationship with the other computers from the same network, your computer have to have an IP address. Without this IP address, it will not be, without proper IP address, it will not be able to communicate in the network. It's like a name for the person. If the person doesn't have name, he will not be able to communicate with the society properly. Now let's take a look for this process of the DHCP through the example. We have two clients, Beric's computer and Seric's computer, in which in Seric's computer we have IP address. Let's say we gave this IP address, or like if it is DHCP client, then it took it automatically. But in Beric's computer we don't have an IP address. And what is happening when Beric's computer is turned on and its Wi-Fi adapter is turned on and it started to think? I don't have static IP address, think the Beric's computer. And without IP address, I'm not proper member of the local area network. I have to find the HTTP server and ask him to give me IP address. Think Beric's computer. How to find the DHCP server inside this network? Imagine that this is the access point, which is connecting the DHCP server and all of these clients all together. And how Beric's computer will find the DHCP server if Beric's computer doesn't know about any one of this local area network. And to make a comparison with this example, let's take a look for this small example. So we have one person which is entering into the room, and inside this room there are, for example, 200 people. And how he will find the person who is looking for? For example, he is looking for the person whose name is Baygabil. And he doesn't know how Baygabil is looking like, and he doesn't know is he here or not. So he decides to ask the question very loudly to screen actually. Okay, and he's saying, "Hey, who is Baygabil?" with the question mark. And after what, if Baygabil will be here, he will give reply. If Baygabil will not be here, so then no one will give reply. For example, Baygabil is here. He say, "Hey, I'm here." The same thing happens with the computer networks when computer is looking for the DHCP server. So computers is deciding to screen, and he say, "Hey, who is DHCP server?" The actually computer can send the packet, which will be directed to all the members inside this network. It will be called the broadcast. So that CRX computer will hear the scream, and he say that I heard the scream, but and DHCP server also heard the scream. What CRX computer will do, he will, I'm not DHCP server, so it is just he is thinking, he is not doing anything, and he is just relaxing. It's not the request for him. And DHCP server says, I am DHCP server. He's thinking about it, and I have to give the answer. And after what he is giving the answer actually, so he say that I am DHCP server, and take this IP address, or he says not take this IP address, he makes the offer. He says like, do you want to get this IP address? And after what, BRX computer decides like, thank you DHCP server, so I'll take this IP address. And here it is. And this is how BRX computer is receiving an IP address from the DHCP server. Now let's take a look for a more detailed example. Just a moment, let's finish this example before. Let's take a look for the more detailed example of the DHCP steps. So we have actually 4 steps. First step, our client is sending the broadcast to all the members inside the network. And only DHCP server will give the reply, and reply consists of the IP address, subnet mask, DNS server's IP address, and the file gateway information. So DHCP server is giving IP and subnet mask. This is mandatory, and this too, DNS and the file gateway, is optional. So maybe it will not provide this information, but maybe it will do. But the things which DHCP server provides exactly, they are IP address and subnet masks. DHCP server gives the offer, and after what, our client is making request, and request is actually like decision to get this offered IP address configurations. And also we have the last step is the DHCP acknowledgement. So the DHCP server says that, alright, you took this information, I mean you took this IP addresses. It is same as for example, we have such kind of situation, scenario. We have the person with the long hairs, and we have, for example, this is girl, let us say, and we have 2 boys, or maybe 3 boys. Alright, let's have 2 of them. And she says, I want to marry. And after what, or like she's saying like, I'm ready to marry, and person A and person B, for example, they also want to marry to her, let us say, and they will give an offer. So first thing, what is happening, well, first step, let's say, she is making a broadcast, and this broadcast says that, for example, I want to marry, I'm ready to marry, and after what, they will give an offer, like, will you marry me, or will you marry me? Oh, this is second step. She has to select one of them. So she is like a DHCP client, they are like DHCP servers, DHCP server and DHCP servers, and she has to answer for the offer for that client, for that server who gave offer first. Okay, for example, if he've been first, then she say, okay, she is making a request. Okay, yes, I want to marry you. And after what, he say, alright, this is acknowledgement. Alright, we will marry. The same thing happens in the DHCP server communications. Like if we have two DHCP servers, and if our computer is making the broadcast, like I want to have IP address, is there is any DHCP server, so then these two DHCP servers are making offer, and their offers will be answered according to the speed of the offer. If DHCP server A will be first, then DHCP server A will get request from the client, and IP address will be given from this server. What DHCP servers provides? It was already listed: IP address, subnet mask, default gateway, and the DNS servers IP address. So let's add it here also. Where are two of these four mandatory? They will be exactly given by DHCP server, and the file gateway and the DNS server's IP address is the optional thing. Now let's take a look for the protocol, which is called for the browser protocols, let us say, which are called SMTP and POP. Simple Mail Transfer Protocol and the Post Office Protocol. And these two protocols are responsible for transmission and the delivering process of the messages. If we'll take a look for the protocol roles which are done by this mail protocols, we will find with you the SMTP protocol and the POP protocol. Whereas SMTP protocol is responsible for transmission data, I mean the mail, and the POP protocol is responsible for the delivering process. Okay, and when your computer is running the mail application, excluding webmail. Actually, we have two types of the emailing. It is webmail, which is available for you through the web browser. So when you are using the web browser, so let's say the web browser, then you use the webmail. When you use external application, which is providing you the emailing, then it is called so let's say just email, not web mailing. And as an example of the email application, it can be a Thunderbird, or maybe it can be Microsoft Outlook. So let me write here MS Outlook. So when you install this application to your computer and run it, then you are using the classic emailing. When you are using the web browser, like with the Gmail or Mail.ru or any other email webmail service, then you are using the webmail. So that's the difference between them. So when you have such kind of application on your computer, then your computer has the role of the MUA. It's like a mail user agent. And you have a specialized web server, I mean the mail server, sorry, which is storing all of your mail information, like your inbox, spam messages, and so on. And when you open this application, actually your computer is making request for the webmail, and after you will get a reply, you will see the list of the messages, you will see the categories of the messages, and so on. Well, when you are sending information from the MUA to the SMTP POP server, you are sending it by using the SMTP protocol. When you are delivering this information from the SMTP POP server, you deliver it by using the POP protocol. Let's take a look for this example in which we have two clients from the different SMTP POP servers. For example, this client is inside the organization, let us say A. This client is inside the organization B. And when client, let us say, client 11 will send information to client 12, Then he will be the sender, and here we'll have the role of receiver. And the client 11 will send the information, will send the mail by using SMTP SMTP protocol to its own SMTP POP server. In this situation, its server will have the role which is called the MTA, Mail Transfer Agent. Between these two servers of different organizations, will have communication into both sides of the direction. We'll have SMTP protocol which is functioning, and when we'll have this mail which is delivered by the SMTP protocol to the server of the organization B, server of organization B will be called the MDA. It's like a mail delivery agent, due to that fact that this mail server is connected to this client, which is a receiver, so that the protocol which is used to deliver the mail is used as the POP protocol is used. In case when you have vice versa communication from client 12 to client 11, in this situation you will have some changes in your topology, so that the client 12 will be sender and client 11 will be receiver, and the protocols will be changed out. So we'll have a row will be changed, and the protocol will be called SMTP. Here we'll have the role of our server, which will be called MTA. Between two servers, as you see, to a row, we have two rows actually from both sides. It will be not changed. The MTA role will be changed to the MDA because it is going to be deliver server, and arrows will be changed also here, and our protocol will be called now POP. And this is same MOA. That is how SMTP and POP protocols are functioning. This is all for the second lesson. Thank you for your attention, and see you in the next lesson.